3 minutes.
Where are we?
Oh no.
And it doesn't look pretty good!
One auditorium. And math?
Oh my god, what? Man, I don't feel pretty good. Ugh, my head's pounding.
Why are all the doors shut?
I don't know, man. I bet I can open it.
Okay then, so we have proven that the doors are locked. Well, Shelly, go get him. Alright, well, why are we here?
I don't know, man, but pretty sure he's dead.
But I know you. All three of you are bad at math, says me. So you are going to do math, or you will be locked in here forever. Yes. I have left you a note detailing your sections. Now, Fatso, read it.
So he said there were... Oh. Hey guys, I found the note.
What does it say?
He wants us to do math. No! Alright, Shelly, my man. Mr. Speaker Man over there says we have to do 2 sections each, and you said you were good at the first 2. I'm just gonna let you handle this one, big boy. I'm out of here. Well, okay then. The first section we're gonna do is solving systems by graphing. The problems are y equals 3x plus 6, and y equals negative 2/3 minus 5. Now, excuse me. There will be a graph edited somewhere by Mr. Speaker Man, so you can understand what I'm talking about. So keep an eye out for that.
Did you show your work?
Yes. Well, I can explain how I did my work. Anyway, this is very basic. You graph the lines using slope-intercept form, which you should already know if you're watching this. Anyway, you do that, and you just and you find where the 2 lines intersect, and that's your answer. Alright, the next section is solving systems by substitution.
What does that mean, kind sir?
It means substitution. I'll explain more in depth on that.
Dang, dude.
Well, alright then. Anyway, our 2 problems are y equals negative 4x minus 8, and y equals 8x plus 4. You put the bottom one right next to the top where the y would be, so they equal each other. Then combine the 2 x's and solve as a normal equation. Be that first part there. Hope you can see that real well. I know my writing's terrible. Sorry. Anyway, but you're not done once you solve for x. X in this case will be negative 1. You have to plug that into one of the other 2 equations and solve for y. I'm going to use the bottom equation because it's simple. Which is and then I'll show my work there in case you can't hear me very well. Alright. Which would be, you just take 8 times negative 1, which would be negative 8, add 4, which would be y equals negative 4, and there's your answer on the graph. My negative 1, negative 4.
Man, turns out it's pretty good.
So it is.
I desire musical entertainment.
Yeah, I have no idea where to go with this.
But I do. I will be solving systems by elimination. All right. It's very simple, and that's coming from me, and I'm horrible at math. What you do is you take 2 equations. For example, I'm going to give the equation y equals 4x plus 2 and y equals negative 4x minus 10. First things first, I'm going to line these 2 equations up and cancel off the 4x and negative 4x because they stop each other. Because, positives and negatives do that jazz. So then that would give me y equals negative 8. My bad. So then I'm going to take it out. I'm going to take -8 and plug it into one of the equations. I'm going to do the first one because it's a little simpler for me, if you get my drift. Okay. So then that would leave us with this little gem right here. -8 equals 4x plus 2. First things first on the realist is you're going to subtract -2 from both sides, giving you a fancy -10 right there. Not -8, not negative another number, -10 equals 4x. Then you're going to divide 4x by both sides. And since I'm a lazy bum and I don't really want to do that, I'm going to pull out my handy dandy calculator, type in a couple numbers, and you get 2.5. It's like magic. I know it looks like 5.2, but that's great. So our answer for x is going to be -2.5. And then since we're solving for like a graphing thing, like what my main man Shelly talked about earlier, we're going to put that legitness into an ordered pair, which would be our x-intercept being -2.5 and our y being -8. Turns out, it's pretty good.
So it is.
All right, the next thing I'm going to be doing is graphing linear inequalities, which is much simpler than it sounds. A scary title like that surely makes a student like me pee my pants at night. First things first is that instead of doing y equals mx plus b like you normally would, we're going to be y is greater than or equal to, less than or equal to, or greater than or less than mx plus b. So, for my example, I took myself a pretty stellar y is greater than or equal to 5x minus 3, which isn't that bad. It's pretty simple, actually. You just take a normal sheet of graph paper, which I don't have, but just trust me, I did it, and just graph it out. And then you take the number 0, great number if you ask me, and you substitute it in for the y and x values, which ends up equaling 0 is greater than or equal to -3, which is a true statement. That is a fact. So then you just take it and you graph it out and then shade in where the 0 should be because it is correct. And being correct is spectacular. But I don't know how to do these next couple of sections because I kind of dozed off during class after this. Dang, dude, I just don't know what to do anymore.
What do you say? Graphing systems of inequalities?
Oh, Nick, there you are. I've been needing your help. Turns out your timing's pretty good.
Alright, so graphing systems of inequalities. It's just like graphing linear inequalities, but there's 2 of them. Alright, so what I'm going to do, where's my paper? Sorry, our speaker man's kind of a mess.
Your whole life is a mess.
Man, if only we actually had an organization crew in here. Man, that'd be nice. Oh, well, he left us with ourselves.
Probably so we can break out of this.
Probably. Oh, there it is. Alright. So let's say I have y is greater than or equal to 3x plus 2, and y is less than or equal to 5x plus 1. Alright, so what you're going to do, you're going to treat both problems just like their regular linear inequalities. Alright, so you're going to have to substitute y and x with 0, 0, which would equal 0 is greater than or equal to +2, which is wrong. So what you're going to do is shade in the opposite area of what you would have shaded in if you would have had that still. And then for the other one, y is less than or equal to 5x plus 1, you do the same thing. And it would be 0 is less than or equal to 1, which is true. So we would shade in the same area that you would shade originally. And next up is exponential rules. Alright, first up we have 0 exponents and negative exponents. Now if you have a number to the 0 power, that will equal automatically 1. So let's say I have 3 to the 0th power, it would automatically equal 1. Alright, next up is negative exponents, which, if you have like 3 squared times t to the negative third power, you take t and the negative third and you would just put it in the denominator place. Like pretend it's one giant fraction. And you will put t in the negative third power in the fraction in the denominator place. Sorry. And then it would be 3 squared over t to the third power. Next up, we have scientific notation. So let's say that you have a really huge number like 1,200,050.
About as big as my bank account, baby.
Actually, I mispronounced that number. 1,250,000. There we go.
Oh, never mind.
And let's say that you have a problem to do. Well, you don't want to write out that huge big number. That would take up too many lines of paper. So what you would do is you would simplify it with scientific notation. What you would do is you would pretend there's a decimal point after the last 0, and you would bring it over so it would be 1 away from covering the whole number. So 1.25 times, and then we have to add up the numbers that we went over. So there was 3 and 6. Yeah, 6. So then it will be 1.25 times 10 to the 6th power. Alright, the next one of exponential rules is simplifying a power raised to a power. So let's say that we have 7x, or not 7x, sorry, I'm still kind of tired. 7 to the 7th power raised to the 9th. Now how that will look would be the 7 to the 7th power would be in a set of parentheses, while the 9th is outside the parentheses. Now what you will do is, you wouldn't add them like we did in the last rule. You would multiply the exponents together, so then you would get 7 raised to the 63rd power. Alright, next up is multiplying same bases with different exponents. Now what you would do is, let's say that you have like 12 to the 12th power times 12 to the 12 squared. You would keep the bases the same, and you would just add the 12th power and the square, which is 2. That way you will get 12 to the 14th power. The final rule for exponents is when you divide them. Now what you will do, let's say I have 7 raised to the 4th power divided by 4 squared. Now what you would do is you would subtract the exponents top from bottom, and then you will keep the exponent, like the answer, on the side that has the biggest exponent, which would be 7 raised to the 2nd power over 4. Now what? I finished my problems.
Man, that was pretty good.
Awesome sauce.
And so it was.
Yeah. Guys, the door's open. We can get out of here.
Let's go.
Congratulations, maggots. Turns out you're pretty good.
Whoa, guys, come on, I'm your friend. It's my